All right, welcome to today's lesson, and this is going to be a live lesson, though the camera is only on me, guys. So we're learning about change in the understanding of the atom. The first guy that we're going to be learning about is Democritus, and he lived from 460 to 370 BCE. So, in your Cornell notes, you're writing down his name, right? Do you think that date is going to end up being important? I would include that in my notes about him. Okay? This is information you need to know. And you can see what I meant about his face here. Well, that's what we have left of him. You know, they didn't have iPhones taking pictures back then. But here's his name. Make sure you get it down. Again, if we go too fast on the video, you can rewind, you can pause. Today, you'll be able to go around to one of the stations if you don't get all the information. But you're going to have to be ready to write. He was a Greek philosopher. And here's some of the information we need to know about him. Democritus was a philosopher who believed that all matter was made of tiny, indivisible particles. Do you think you need to write every word there? I would try to break it down. Like, what does he believe? Everything's made of what? Well, what does he say, though? Tiny, indivisible particles. Indivisible means it can't be split apart. That's what I would write. He believes everything. We know now everything's made of atoms. He's the first one to say everything was made of tiny, indivisible particles. He also determined through his belief that you could not divide matter forever. There had to be a single particle that made up everything. There, I would just write down for my second bit of information, the single particle that made up everything. Because he's saying, we know, like if I have this popsicle stick, I can split this popsicle stick, right? And if I split it once, I can split it again. And then I could split it again. And if I had something else, I could split it again and I could keep splitting it. But eventually he's saying it can't be split. That's the single particle that made up everything. What we now understand as an atom. He called the particle that could not be split atomos, Greek for undividable or uncuttable. They thought it was kind of like a solid, steel ball. That's what it was going to be like. Next scientist, after some of our students have decided that John Dalton is cute, is John Dalton. Lived from 1766 through 1844. And he is a British scientist. So the United Kingdom, that island across the Atlantic Ocean, he's a British scientist. He studied gases and formed his atomic theory. The main points of it are, so atomic theory is a big thing with Dalton, okay? Just kind of like our last guy, he knew elements are made of extremely small particles. He continued the use of that word atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size. He also, like our last guy, thought that atoms cannot be subdivided, created, or destroyed. But here's some of his big things. Atoms of different elements combine in simple whole number ratios to form chemical compounds. So he comes up with the thought about chemical compounds being different elements combined in simple whole number ratios. He also thought in chemical reactions, atoms are combined, separated, or rearranged. What happens when you do that chemical reaction? Remember when we talked about the volcano and you've got this, you're making your volcano in class, and that's a chemical reaction, right? It starts fizzing, going all over the place. So he thinks atoms are either being combined, separated, or rearranged. These two are really big. You should also know that he's continuing some of the same thoughts as our last scientist. You'll see all of these scientists sort of build upon each other. Unlike Democritus, he actually studied the atom scientifically. So back in the day, Democritus, he's thinking about it, right? He's questioning, talking about it with people, but he doesn't have scientific equipment to study it. Dalton's going to be the first guy that's going to do that. This is what his model looked like. Remember, Democritus thought it was like a solid ball that couldn't be split. He's also saying it's a solid sphere model or bowling ball model. That's what he thinks the atom is like. That's what his studies are showing him. So everybody should have J.J. Thomson Moses and his dates from 1856 to 1940. He is also a British scientist. You'd find, looking at these guys, that most of them either worked together or like one was a student of another. So there's almost like a continuous line. Excuse me. So he's a British scientist. He had studied Dalton extensively. That means a lot. Okay, so he had studied his work. He determined through his studies that there were smaller particles than atoms, and those particles make up atoms. Do we know that to be true or false? Did we learn about particles in the atom?
Oh, yeah.
What did you learn? Protons, what else? Neutrons and electrons, good. He referred to the particle he discovered as a corpusculus. I doubt I'm pronouncing that right. Those are now called what? Electrons. So basically, he discovered electrons. We already know that electrons are the really small, negatively charged stuff. So do you need to write that again if you know it? If you know it, you don't need to write it again. I like how you remembered faster than Flash. But yeah, so he thought the electrons were just stuck there. You guys were right in that you remembered that we know now that electrons moved really fast, like the speed of light. But here's his model. So his understanding is this plumb. What was his understanding that... So Ernie, with his crazy colors there, Rutherford, where do we think he's from?
The UK.
Let's see. He's another British scientist. He was born in New Zealand, which is just above Australia. Well, but a lot of them are... Excuse me. Hey, British scientists, born in New Zealand. One of the reasons you're going to see a lot of these guys from the same place is because they studied under each other. We see here he did research under J.J. Thomson at Cambridge University. He is famous for what is known as the gold foil experiment. I hope when you're hearing that, you're asking yourself, well, what is the gold foil experiment? Because you're going to want to know about it. He discovered through his experiments that the atom has a small, dense, positively charged nucleus. Why is the nucleus positive? What's in it? But what is in it that's positively charged? Boom, yes, there you go. Protons are in there. Right now, he just knows it's positively charged. And he discovered through his experiment that most of the rest of the atom was empty space. Listen, each scientist, we're getting a look at how they saw the atom. What he's seen is they have this positively charged nucleus. Does he believe in the plum pudding idea? No, you can see it, right? He's got these circles. He knows there's stuff going on, and there's nothing in a large part of it, but you have the negative charge stuff flying around it. Okay? So again, I would draw it, take some notes. What does he think's happening? The big thing is understanding, why does he think some just pass through and nothing happens? Why do some mostly pass through but they get deflected a little bit? And why does every once in a while one comes bouncing back? What does he believe about that? Ford thinks, Moses, that every once in a while that particle hits the nucleus, comes back. But a lot of the atom is just space, so it passes through. Every once in a while, it runs into one of these electrons and sort of, goes zinging off to the side a little bit. But only if it hits the nucleus does it come straight back. Heading down to start. Niels Bohr, 1885, 1962. And he is a Danish scientist. No, somebody else said it before you, Moses. All right, so we know. Let's see what he came up with. He conducted research at Cambridge where he met who?
Ernest Rutherford.
Rutherford. As you see, these people know each other. He might have met his wife there too. Who knows?
Exactly. So if you think about it, are they really smart? Because they just get like stuff off of each other.
Oh my goodness, yes. Thank you for talking about how we should all build upon each other's thoughts. He was invited to research at Manchester University, again by Rutherford. He created the planetary or Bohr model of the atoms, where he believed that electrons move in specific orbits or shells around the nucleus. And an orbit is just like what the moon does to the Earth. It orbits around. It circles around us. Okay? Oh, I know since you're talking, you have this, that he's thinking specific orbits. Like how many can go in that inner orbit? Right here. Two. Only 2 electrons. He's talking about the electrons moving around. Okay? I would draw a picture. You don't have to have the exact number, but you need to have the orbits. Okay? I would draw it, yeah. No. So, you've got our guys here, 2 of them working together. He couldn't quite get his hair combed. So, which one did you want to go out with?
That one.
This one?
Yeah.
Not him? Okay. So apparently my students are checking out each scientist, wondering which one they would date, according to their Tinder picture right here. They are all Austrian and German scientists. Austrian and German scientists. It's the same area of land.
Why are they both together?
So, you're going to find that out probably. They both studied who extensively? Bohr, the Danish scientist. So that extensively a lot. They separately, not together, created new models of the atom different than Bohr's. Again, the reason you had 2 people, one is using the other's math, the formulas they've come up with to create their model. The model is known as the electron cloud model. The model takes the electrons out of specific pathways and into a cloud. That's what it looks like. Electron cloud, the nucleus. Okay? If it's a cloud, what do you think would be holding these things together?
The electron.
Right. Have you ever used a magnet?
No.
You've never used a magnet. In elementary school, they never said, here's a magnet, pick up stuff. You got a question.